This is Unit 2, Segments, Lines, and Angles. Preview video 2.8, Proving Parallel Lines. Sit tall where you're at. Just take a deep breath in through your nose. Ready? Inhale. Breath. You're taking a look right here in your notes. Don't forget date, time, and location, as well as a parental sign-off. Proving parallel lines. So last class, we learned this. Proving parallel lines. Last class, we started with the premise, if you have parallel lines, then certain things happen. If you have parallel lines, then we have either angle congruent to angle, as in alternate interior, alternate exterior, corresponding. And if you have parallel lines, then you would have angle plus angle equals 180. That would be consecutive interior. So we start with the premise, if you have parallel lines, then these four things happen. 1, 2, 3, 4. This lesson says this: if certain things happen, then you have parallel lines. It's proving. It's what we call the converse. So if you either have any one of those four, angle equals angle, that's 3 of them, or the angle plus angle equals 180, that's 1 of them. If one of those scenarios happen, then it forces lines to be parallel. For example, right here, if I told you lines angle 2 and 7 are congruent, even though the line L and M don't look parallel, they would be considered parallel because alternate interior angles are congruent. This is called proving parallel lines. So last class we had this. If you had parallel lines, then you either had angle equals angle or angle plus angle equals 180. And it was one of these four scenarios. If you have parallel lines, alternate interior angles would be congruent, like 3 and 6. If you have parallel lines, alternate exterior angles would be congruent, like 8 and 1. If you have parallel lines, then corresponding angles would be congruent. That would be like angle 6 and 2. And if you have parallel lines, consecutive interior angles such as 3 and 5 are supplementary. So all of this starts with the fact, if the lines are parallel, then these things happen. That was last class. This class says this: if you have certain angles that are congruent or certain angles that are supplementary, then you have parallel lines. So if we were to look at this diagram, we see that line L and M don't look parallel. But if you were told angles 6 and 3 congruent, alternate interior angles, then line L and M would have to be parallel, even though they don't look like it. If a pair of alternate exterior angles are congruent, such as 1 and 8, then the lines would be forced to be parallel. If corresponding angles are congruent, such as 7 and 5, then the lines would have to be parallel. And if I told you angles 2 and 3 added up to 180, then the lines would have to be parallel. So if you notice, the order is opposite. Something happens, then lines are parallel. Let's show this in a couple problems. Now, when I say the term stir stick, I want you to lay down, if you have a physical stick, it would be very helpful if you lay down a certain object. Let me give you an example. In this diagram, you're told if 1 and 4 are congruent. So 1 and 4 are here. So your stir stick has to touch both those lines. So your stir stick goes here. And if 1 and 4 are congruent, you're being asked which lines have to be parallel. Trace with me. You can see that 1 and 4 are alternate interior, or otherwise known as armpits of the Z. So if 1 and 4 are congruent, line SP, segment, should be parallel to QR, and the reason would be if alternate interior angles are congruent, then the lines have to be parallel. But you have to be specific. It's not any old segment. Ready? We're going to try another set here. We are told this: if PQR and QRS are supplementary. So if you squiggle these angles, PQR, so P to Q to R, sweep, and QRS, QRS, trace and sweep, you will notice that our stir stick has changed. The two angles are hugging or right next to that segment. Therefore, these are the lines that now must be parallel. So the lines that are parallel because of these two would be R, Q is now parallel to SR, and the reason would be is because these angles right here are consecutive interior angles, and you are told that they are supplementary. So if consecutive interior angles are supplementary, then you have parallel lines. This page I'd like you to try on your own. And restart the video when you're done. Welcome back. Okay, let's take a look at what you did. It says if 2 and 3 are congruent, what you would have here would be armpits of the Z, which would force BC to be parallel to DE. So in this case, BC would be parallel to DE, again, even though they don't look like it, but because you're told these angles are equal. So why would that be? You would write if alternate interior angles congruent, then you have parallel lines. Here's another scenario. If 1 and 2 are congruent, so 1 and 2. Here, your armpits of the Z would be this way, armpit of the Z, which means your parallel segments now are AB and CD. So AB is parallel to CD, and the reason is if alternate interior angles are congruent, then you have parallel lines. Take a moment and verbally recap what you have learned in today's lesson.